Here we're trying to identify which set is an inverse from each other. So first I would eyeball these and look for inverse operations. Those are operations that are opposite from each other. A looks almost like the same thing, except this plus is changed into a minus. But I would also look here, and we still have x divided by 5. If those really were inverses, I might expect to see an x times 5 in the inverse function. Now moving on to b, I see that we have an x cubed. If g were the inverse, I would expect to see a cube root of x, or maybe an x to the 1/3 power. That would be the same thing. So I'm going to eyeball number c. We have an x squared. We have 7 times x squared plus 8. This looks like it might be a good candidate. I see that we're subtracting 8 divided by 7. I see we have a square root. So I'm going to go ahead and look at c more closely and copy it down. I'm going to change that f of x to a y. And then I'm going to go through the steps of finding the inverse, which is to replace the y with x and the x with y, and then to solve for the y. So first I'd subtract 8 from both sides, and we get x minus 8 equals 7y squared. And then we would divide both sides by 7. That would give us x minus 8 divided by 7 equals y squared. And to undo that square, we would take the square root of both sides. So that would give us y equals square root of x minus 8 divided by 7. And it looks like that's exactly what the g function is. So now I've sort of proven it to myself that that is actually the inverse function. So I'm going to select C. I just want to point out one thing with D, though. This is sort of close, but look at that exponent on the x. It's 2/5, and this is also 2/5 exponent. If g really were the inverse, I should expect to see some kind of x to the 5/2 maybe.